Hello and welcome to the presentation. In continuation with the previous video of demonstrating the conduction of current in the semiconductor, where we discussed the conduction of current in pure semiconductors. Now we continue the presentation with the conduction of current in doped semiconductors. Now, considering a p semiconductor bar here at 0 degree temperatures, when it is connected in the external circuit like this, even at 0 degree centigrades, the p semiconductor will be having a large number of positively charged holes. This is due to the doping of a trivalent acceptor impurity into a pure semiconductor material. And due to the presence of these charge carriers, current can be conducted even at absolute 0 degree centigrade in case of the doped semiconductors. When these doped semiconductors are subjected to the room temperature, in addition to the existing holes, thermally generated electron hole pairs will be included in the semiconductor bar. As a result, there will be large number of positive charged holes and a few number of negative charged free electrons will be present in the semiconductor bar. The positively charged holes will be traveling away from the positive terminal towards the negative terminal inside the p semiconductor bar, and it is directed by the continuous dark arrow here. Free electrons will be entering from the negative terminal end into the p semiconductor bar, and when they occupy the free site of electron, the hole in the semiconductor bar, they become valence electrons and continue their travel from negative terminal towards this positive terminal as valence electrons only and constitute the huge current in the p semiconductor bar. And this huge current is due to the holes which are present, large number of holes which are present in the p semiconductor bar, and is called as the majority hole current. However, there are a few thermally generated free electrons present in the semiconductor bar, which will be traveling from negative terminal towards the positive terminal and through the external circuit towards the positive terminal of the voltage source as directed by the dark line here. This movement of a few number of free negatively charged electrons constitutes small current, which is called as the minority electron current. The total current in the semiconductor bar will be equal to the majority hole current plus the minority electron current, as much of the current is due to the conduction of valence electrons through the positive charged holes in this p type of semiconductor. Holes are called as the majority charge carriers in p semiconductors, and a few number of free electrons which constitute only a small quantity of the current are called as the minority charge carriers in the p semiconductor bar. In the external circuit, the direction of current is always represented opposite to the direction of flow of electrons. That is why the direction of current in the external circuit is shown from positive terminal towards the negative terminal of the voltage source. In case of the N type of semiconductor, as the pure semiconductor is doped by a pentavalent donor impurity substance, even at 0 degree centigrade temperature, there exist a large number of free electrons in the N type of semiconductor bar. This makes the N type of semiconductor bar to conduct electric current even at absolute 0 degree temperatures. When this N type of semiconductor bar is brought into the room temperature, thermally generated electron-hole pairs will be included in the N type of semiconductor bar, creating more number of negatively charged free electrons and only a few number of positively charged holes in the N semiconductor bar. And these holes will be conducting the valence electrons, and holes are seen to be moving from the positive terminal towards the negative terminal inside the semiconductor bar, conducting the valence electrons from the negative terminal towards the positive terminal inside the semiconductor bar, constituting the small minority current due to the holes, which is called as the hole current. Large number of free electrons present in the N semiconductor bar will be moving from the negative terminal here towards the positive terminal and reach the positive terminal of the voltage source in the direction mentioned with the continuous large arrow. Due to the large number of free electrons, the current will be the huge one and is called as the majority current due to the free electrons. The total current in the semiconductor bar is equal to the minority hole current plus the majority electron current here. As the contribution of free electrons is more for the current conduction here, free electrons are called as the majority charge carriers and holes are called as the minority charge carriers in N type of semiconductors. In the external circuit, the direction of current is shown opposite to the flow of electrons, and that is why it is shown as flowing from the positive terminal of the voltage source through the external circuit towards the negative terminal of the external voltage source. This is how the current is conducted in case of the doped semiconductors. With this, I am signing off. We'll meet you in the next video.